Have you ever stick a battery in the wrong way or switch up the red and black power wires? If so, a diode might be to thank for your circuit still being alive. A diode placed in series with the positive side of the power supply is called a reverse protection diode. It ensures that current can flow only in the positive direction and the power supply only applies a positive voltage to your circuit. This diode application is useful when a power supply connector isn't polarized, making it easy to mess up and accidentally connect the negative supply to the positive of the input circuit. The drawback of a reverse protection diode is that it will induce some voltage loss because of the forward voltage drop. This makes Schottky diodes an excellent choice for reverse protection diodes. Now, let's talk about logic gates. Forget transistors. Simple digital logic gates like the AND or the OR can be built out of diodes. For example, a diode 2-input OR gate can be constructed out of two diodes with shared cathode nodes. The output of the logic circuit is also located at that node. Whenever either input or both is a logic 1 means high or 5 volts, the output becomes a logic 1 as well. When both inputs are a logic 0 means low or 0 volts, the output is pulled low through the resistor. An AND gate is constructed in a similar manner. The anodes of both diodes are connected together, which is where the output of the circuit is located. Both inputs must be logic 1, forcing current to run towards the output pin and pull it high also. If either of the inputs are low, current from the 5-volt supply runs through the diode. Diodes are often used to limit potential damage from unexpected large spikes in voltage. Transient voltage suppression diodes are special diodes, kind of like Zener diodes, lowish breakdown voltages, often around 20 volts, but with very large power ratings, often in the range of kilowatts. They are designed to shunt currents and absorb energy when voltages exceed their breakdown voltage. Flyback diodes do a similar job of suppressing voltage spikes, specifically those induced by an inductive component like a motor. When current through an inductor suddenly changes, a voltage spike is created, possibly a very large negative spike. Let's try to understand this circuit using our circuit simulator. So, here we are. Our inductive component will be this motor here, and we turn on this motor using a transistor and a switch. Now, I know we didn't learn about transistor yet, but just imagine transistor like a switch, and if it's turned on, it conducts current, and if it's turned off, it doesn't conduct current. Now, when I turn on the transistor, you will see that current starts flowing from the 5 volts power supply through the motor, through the 100 ohm resistor, which is here to limit the current, and to the ground. Now let's see what happens if I take out the diode and I want to turn off the motor. Because the current through this inductor suddenly changed because we turned off the transistor, a voltage spike is created, which is a negative spike. As you can see, our simulator got crazy a little bit. The signal should look something like this, but instead it started oscillating. But if we look carefully, we will see that the negative voltage spike that was generated is at minus 10 kilovolts. This is a huge negative spike, and it can cause damage in our circuit and destroy our transistor. We can obviously not afford to buy a new transistor every time we want to turn off the motor. Now let's try to repeat what we just did, but this time with the flyback diode back to its position. As you will see this time, when I turn off the motor, The flyback diode placed across the inductive load will give that negative voltage signal a safe path to discharge, actually looping over and over through the inductor and the diode until it eventually dies out.